Nir Joseph Shaviv is an Israeli-American physics professor carrying out research in the fields of astrophysics and climate science. He is a professor at the Racah Institute of Physics of the Hebrew University of Jerusalem, of which he is now its chairman. He is best known for his solar and cosmic ray hypothesis of climate change. In 2002, Shaviv hypothesized that passages through the Milky Way spiral arms appear to have been the cause behind the major ice ages over the past billion years. In his later work, co-authored by Jan Weiser, a low upper limit was placed on the climatic effect of CO2. His best-known contribution to the field of astrophysics was to demonstrate that the Eddington luminosity is not of strict limit, namely, that astrophysical objects can be brighter than the Eddington luminosity without blowing themselves apart. This is achieved through the development of a porous atmosphere that allows the radiation to escape while exerting little force on the gas. The theory was correctly used to explain the mass loss in Racah Carina's giant eruption and the evolution of classical nova eruptions. Education and career. Shaviv studied, during 1987–90, physics at the Racah Institute of Technology in Haifa and finished his BA as best in class. During his military service he continued his studies 1992 and co-authored his first papers in astrophysics. In 1994 he received a Master of Science in Physics and a doctorate during 1994–96. During 1996–99 he was a Lee Bridge Prize Fellow at Caltech's Taper Group. During 1999–2001 he was in a postdoctorate position at the Canadian Institute for Theoretical Astrophysics. In 2001–06 he was a senior lecturer at Racah Institute of Physics at the Hebrew University of Jerusalem. In 2006–2012 he was an associated professor, and full professor since 2012. Between 2008 and 2011 he was the head of the Faculty Union of the Hebrew University, and he served as the chairman of Coordinating Council of Faculty Unions between 2010 and 2014. In 2014 he became a member of the Institute for Advanced Study in Princeton, and chairman of the Racah Institute of Physics in 2015. Scientific research. Eddington luminosity limit. In 1999 Shaviv has shown that inhomogeneities in stellar atmospheres reduce the effective opacity and thus increase the Eddington luminosity. Shaviv later showed that atmospheres are inherently unstable as the Eddington luminosity is approached, that these atmospheres will develop continuum-driven winds that explained the appearance of Racah Carini and classical nova eruptions. In 2010 Shaviv made the prediction that type IIN supernova should have super-Eddington outbursts before the main supernova explosions, since the super-Eddington states can naturally explain the circumstellar material present around the supernova at the time of explosion. Such precursors were later detected with the Palomar transient factory, making them the first systematically detected supernova precursors. Cosmic rays and climate. Shaviv has been one of the proponents of a cosmic ray-climate link. In 2003 he has shown that the cosmic ray flux over the past billion years can be reconstructed from the exposure ages of iron meteorites, that these flux variations are expected from spiral arm passages, and they correlate with the appearance of ice age epochs on Earth. In a later work with Jan Weiser, it was demonstrated that the temperature reconstruction over the Phanerozoic correlates with the cosmic ray flux, but it does not correlate with the CO2 reconstruction, thus placing an upper limit on the effects of CO2. This prompted several reactions by the climate community and rebuttals by Shaviv and his colleagues. He has also showed that the cosmic ray climate link explains part the faint sun paradox, since the slowly decreasing solar wind will give rise to a cooling effect that compensates the solar irradiance increase. Moreover, long-term star formation activity in the Milky Way correlate with long-term climate variations. In a more recent work with Andreas Prokop and Jan Weiser, it was argued that the reconstructed temperature has a clear 32 million year oscillation that is consistent with the solar system's motion, perpendicular to the galactic plane. The oscillation also appears to have a secondary modulation consistent with the radial epicyclic motion of the solar system. Solar variation and climate sensitivity. Because the existence of a significant cosmic ray climate link implies that solar variability will also have a large effect on the climate. Shaviv advocated the idea that natural climate variations play a significant role in 20th century climate change. Moreover, if solar activity increase over the 20th century contributed to warming in addition to the anthropogenic forcing, then the overall climate sensitivity should be lower than advocated by standard scenarios which do not include solar forcing. In 2008, Shaviv used the oceans as a giant calorimeter to quantify the solar radiative forcing. He found that the peak-to-peak variations are close to 1 W per square meter, significantly more than can be expected from the changes in the solar irradiance. In 2011 he published a paper with Shlomi Ziskin arguing that the solar variability explains about half the 20th century warming, with the other half attributable to anthropogenic forcing. Shaviv's solar hypothesis has been disputed by Mike Lockwood and Klaus Froelich in an analysis of the Sun's output over the last 25 years. They argue that the Sun's activity has been decreasing since 1985 while global temperatures have continued to rise. Shaviv argues that Lockwood and Froelich's analysis is flawed for a number of reasons. Firstly, while sunspot activity declined after 1985, cosmic ray flux reached a minimum in 1992 and contributed to warming during the 1990s. Secondly, Shaviv argues that short-term variations in radiative forcing are damped by the oceans, leading to a lag between changes in solar output and the effect on global temperatures. While the 2001 maximum was weaker than the 1990 maximum, increasing solar activity during previous decades was still having a warming effect, not unlike the lag between noon and the hottest hour of the day. The recent lack of warming is consistent with the decreased solar activity. Thoughts on global warming. Shaviv was interviewed for the Great Global Warming Swindle documentary. In the film he states, in 2012, he contributed, along with Werner Weber, Henrik Svensmark and Nicholas Kafeta, to the book Die Kaltson, Warum die Klimakatastrophe nicht stattfindet of Fritz Fahrenholt and Sebastian Leuning, a book expressing skepticism of anthropogenic global warming, which attracted considerable interest in Germany. Numerous scientists criticized the book and considered its underlying assumptions to be either outdated or highly speculative. Prizes and awards. 1996 Wolf Foundation Award for Excellence as PhD Student. 1996 Leada Bridge Scholarship at Caltech. 2000 Beatrice Tremaine Scholarship in Toronto. 2004 Siegfried Samuel Wolf Lecture for Nuclear Physics. 2014 IBM Einstein Fellowship, Institute for Advanced Study, Princeton. Selected papers. Elphick, C. Regev O. and Amp. Shaviv, Nir J. Dynamics of fronts in thermally bistable fluids. The Astrophysical Journal, 392-106, Bibco, 1992 APJ, .392, 106 EDO 10.1086, 171,410. Shaviv, Nir J. Nonlinear structure formed the era of decoupling. Mon. Not of the Royal ASTR. SOC 297-1245 Arxiv Astro PH 9804292 Bibco 1998 MNRAS 297.1245 SDOI 10.1046 J 1365-8711.1998.0160 X. Da Laorn Amp. Shaviv, Nir J. Life Extinctions by Cosmic Ray Jets. Physical Review Letters 80. 5813-5816 Arxiv Astro PH 9705008 Bibco 1998 PHRVL .80 5813D DOI 10.1103 Fizrevlet 80.5813 Shaviv, Nir J. The Porous Atmosphere of H. Carini. The Astrophysical Journal Letters, 532, L137, Arxiv, Astro PH 002212, Bibco, 2000 APJ, 532 L. 137 SDO on 10.1086, 312,585. The spiral structure of the Milky Way, cosmic rays and ice age epochs on Earth. New Astronomy 839, Arxiv Astro PH 02092252, Bibco, 2003 Newer. 8. 39 SDO on 10.1016 S1384107600193 Visor Jan Celestial Driver of Phanerozoic Climate GSA Today 13 4-10 DOI 10.1130/1052-5173013 and LT semi:0004:CDO PC and GT semi:2.0.co 2. On climate response to changes in the cosmic ray flux and radiative budget. J. Geophys. Res. Space Phys. 110. A08105. Arxiv Physics 04091123. Bibco. 2005 JGRA. 11008105 SDO on 10.1029 2004 JA010866 Scherer K. Fichtner H. Bormann T. Beer J. Desorger L. Flukiger E. Farr H. Ferreira Shea A. Al. Interstellar terrestrial relations, variable cosmic environments, the dynamic heliosphere, and their influence on terrestrial archives and climate. Space Science Reviews 127. 327. Bibco, 2006 SSRV. .127. 327 SDO on 10.1007 per seconds 1121400691266. Lectures. Shaviv, Nir J. Climate Change and the Cosmic Ray Connection. International Seminar on Nuclear War and Planetary Emergencies. 30 Teschen, Paris, Italy. Ed. R. Racah Institute. World Scientific Check. Date values in year equals date equals mismatch.